Hello, this is Hui. Welcome to watch my video C++ programming on Linux. In this short video, it will continue discuss Libevent, a fast, portable, no blocking network programming library. Libevent is an event notification library for developing scalable network servers. It is one of popular libraries used in network development. In this short video, we are going to focus Libevent-evhttp. Libevent-evhttp provides a very simple event-driven HTTP interface that can be embedded into your program for making HTTP requests and for creating a very simple HTTP server. The example of this video is using evhttp provided HTTP functions to build a very simple HTTP server and a client making HTTP requests. Here on Linux, we create a two C++ program, evhttp HTTP server, evhttp HTTP client.cpp. To use evhttp, the header file will be evhttp.h and event2/http.h. For server, the usage will take one argument from command line, which is the port number. The IP address for server will be the 0.0.0.0. It means we accept all requests. First, we get IP address and port number. Port number from the argument 1. Next, step 1, create a new event base. We name it base equal Step 2, create a new HTTP server. Step 3, bind the HTTP server on a specified address and port numbers. First parameter is the HTTP server. Second parameter is the HTTP address. Third parameter is the port number. Step 4 will be set callback function for all requests. GNCB general callback. First parameter HTTP server. Second parameter is the callback function name. We name my request reply, and the third parameter will be the argument passed to this callback function. In this example, we don't pass anything. We take none. Next step, step 5, we're going to create a signal event to pick signal Ctrl+C for exit from event loop. First parameter is the base. Second parameter is the signal, SIGINT. In previous video, we had one video to discuss the Linux signals. Here is the list of all Linux signals, and the signal SIGINT is the process was interrupt. This happens when you press Ctrl+C on the keyboard. We set this event to pick up this signal for exit from event loop. Callback function will be my, and we pass parameter base. Add this signal event to the base. Print information. First is the address, second port number, third is handle, set event active. Before exit, free our HTTP server, signal event, and the base allocated memory. Free signal event. Free the event base. Now we start programming callback. First, we are going to programming our signal event callback. Function mySignalEventCB is a callback function of signal event SingInt. In this simple example, signal SingInt is designed for exit HTTP server. So if there is some action need to perform during exit, it can be placed here. For example, write HTTP server exit time into log file. In this simple short video, since there's no logic or action it need to perform here, so we just print a debug message on screen and break event loop. Step 1, parse and decoding the argument. Since the argument passed to this function is the event base, so we just cascade the pointer struct event base. And call the function event base loop break. Function myRequestReply is the callback function of all requests. In this function, we're going to allocate a buffer for reply, get and parse request URI, write HTTP reply to the buffer, send HTTP reply, and free the allocated memory. First, allocate memory. Name is reply. Get the URI from the request. Name request URI equal. Get the host from the request. Parse our request URI. If not parse the URI, send byte HTTP request and then return. Next, get command from request. For HTTP command type, one, two, three, four, five, six, seven, eight, nine type. HTTP request get, post, header, put, delete, options, trace, connect, and patch. So we copy this 1, 2, 3, 4, 5, 6, 7, 8, 9 line. We paste it here. Command type get. Using switch, we can direct based on the different command type received to do the different things. In this short video, we just print out which command type we received. First, request URI. Second is the command type. Third one is the request host. Next step, we're going to build HTTP reply. Usually HTTP server reply HTML string. So we just print a simple hard coding HTML string back to the client. And the reply buffer, HTML into the reply buffer. Next, send reply function. The status, okay. If we parse the URI, free parse the URI, free allocated memory reply. Now we finish our simple HTTP server program. We save our program. We're going to next program, evhttp client.cpp. Usage of HTTP client take two arguments from command line. First argument is the host or URI. Second argument will be the port number. To write a program using evhttp making HTTP request, the header file will be the evhttp.h, event.h, http.h, and event buffer.h. Next, create event base object, create a connection object, and create a new request object. Usually, HTTP request has a header and body, so we can set a request header, then making HTTP request function evhttp make request. Before HTTP request event, we can set up a connection option like a timeout, number of retry, and dispatch action using the event-based dispatch. First, we declare some pointer, event base, connection object pointer, CONN, request object pointer, REQ. First, we get a host and port number from command line. Argument 1. Port number from argument 2. Create event base. Create a connection object. Parameter base. Second parameter now. And the third parameter request host. Create a request object and the callback function we name base. Next, we can set up a request header. For this simple example, we just hard coding set up a very common field request header. Request output header. Common HTTP header field like a host, content type, connection, and content length. So we just set up two for this simple program. Next, it's going to make HTTP request function, HTTP make request. First parameter connection, second parameter a request, third one is the command type from root. Optionally, we can set up a connection option, for example, timeout, number of retry, and IPv4, IPv6. Set up 600 seconds. Next, dispatch active event base. Now we finish our main function. We're going to write callback function HTTP request CB. Function HTTP request CB is the callback function for request object. In this function, it's going to allocate the memory for reading response from HTTP server, make a loop, read from request, input buffer, and print the date on screen. And then using event-based loop break to break the active event. We declare the maximum size 1024. First, declare the buffer. Memory set our buffer, to make a loop. Function ev buffer remove read date from event buffer into the local buffers. Event input buffer, local buffer. This function returns number of byte read. Read the date from the input buffer, then print date received. We print out the buffer and memory set our buffer for next read. Finish the reading, we just break our event loop. Finish our request callback function. We save our program, compile our program. Now program has been compiled. Now we got our executable EV-HTTP client and the EV-HTTP server. To test our program, we're using two terminals. Both terminals are located at the same directory where we compiled server and the client executable. Server IP address is 1.0.0.191. Here is our executable EV-HTTP HTTP client, EV-HTTP HTTP server. First, we start a server, port number 1234. Now our server started. We're listening to the port number 1234. We check. You can see our server has started listening port number 1234. We try to run our client, EV-HTTP HTTP client. Host will be the 1.0.0.191, port number 1234. You can see we got a response back, HTTP reply. Since this is a HTTP server, we can also use in the browser to check. We just type the address, HTTP 1234. You can see this is our simple page. We test lab event HTTP server. HTTP server is very popular and widely be used these years. And there are many tools, languages are available for building HTTP server and client. C++ is not one of popular language for making HTTP server. The advantage of lab event EV-HTTP provided very simple event-driven HTTP server. It's lightweight, fast, and high performance. It's easy to embed it into your original program. Hello, this is Hui. Thanks for watching my video. Wish it is useful and it's going to be great to have your feedback.